Hello, everybody. I'm Pat Patterson, and welcome to this virtual SmallSat conference webinar today with our keynote speaker, Dr. Chris Scalise. He's the director of the National Reconnaissance Office. Today, we have about an hour with Dr. Scalise, and if anyone has any questions, we'd love to get them in. Please feel free to send them in using the Q&A button, and then I'll see them here, and we'll be able to curate a few of those and get some of your questions asked. We'd love to hear what you have to say. Just sort of as a note, we've got somewhere in the neighborhood of 1,000 listeners today, so pretty good turnout. But with that, let's get right to it. We're very happy to have Dr. Scalise join us today. He was appointed as the 19th director of the National Reconnaissance Office in August of last year. He began his government career as a United States naval officer in 1978. And in 1987, he joined NASA at the Goddard Space Flight Center. In 2012, he went on to serve as the director of Goddard, where he led the nation's largest organization of scientists, engineers, and technologists responsible for building spacecraft, instruments, and other new technologies to study the Earth, the Sun, our solar system, and the universe, not the university. But that's quite a bio, Dr. Scalise. We're very happy to have you. So welcome today.
Thank you, Pat. I appreciate the introduction.
Yep.
Glad to be participating. I was going to say glad to be there, but I'm not.
Yeah, we'll get you here sometime in the future, but we appreciate your help today and working through all this. By the way, I really need to give a big shout out to your staff. They've been incredibly helpful throughout this whole process. So please pass along our thanks to them. So
absolutely, they're a great team.
Yeah, let's get right to it. You've been the director of the NRO for about a year now, right, after coming over from NASA. Can you compare and contrast, and we're getting these questions from our listeners, can you compare and contrast your experience at NASA versus the NRO and how you're utilizing small satellites for technology demonstrations or operational missions?
Certainly. Well, I mean, when you think about it, NASA and the NRO, at least the space part of NASA and the science part of NASA, we, like the NRO, operate in space. So we have utilize a lot of the same resources. The Florida launch site, Cape Canaveral or Kennedy Space Center, or both. Vandenberg, other launch sites around the country and the world. You go to often the same teammates in terms of the industrial base and the university base. So there's a lot of similarities between the two organizations. And at the same time, they're both staffed by incredibly capable people. I couldn't ask to be in two better organizations. And I'm really glad to be here now at the NRO with the great women and men here who serve our nation and continue to deliver the information that's needed by our nation and the world to keep us safer. So they're very similar. About the only difference between NRO and NASA is so far the NRO is not going to Mars or Jupiter or someplace like that. We tend to be focused very, very strictly on the Earth.
Yeah.
And in terms of small sats, even there's a lot of similarities. Small sats can provide lots of opportunities to do science, to provide information for the intelligence community, and to allow us to develop technologies, capabilities, and personnel as we try and move into the next generation of systems. I think when anybody that saw the video that I did, you saw that our early satellites at NRO were relatively small, as were most satellites back in that day. And clearly, you need to build the satellite for the mission. So size and numbers and orbits are all determined by the physics of the problem. But CubeSats provide something that allows us to respond more quickly. We can use that for technologies. to go off and develop them. I mentioned that earlier about our programs here. NASA has similar programs. Typically with a CubeSat, you can get it up in 1 to 3 years, sometimes faster. And the price to orbit is much less because you can ride share. So there's lots of opportunities for CubeSats. And then as we're seeing, they with the advances in electronics and other systems, we're able to do more with smaller satellites. So I'll stop there because I know you have other questions that will go into other details.
Yeah, yeah. How about, by the way, with your long history at NASA, go Mars Perseverance, right? That was really cool this last Thursday, and then yesterday we were in here, for the conference, and we had Bob and Doug coming back from space on the TV live, and we watched that. That was a pretty amazing thing to see manned space flight coming back to the U.S. on U.S. systems.
Absolutely. I mean, it's I've been associated with all of those programs, and it's great to see the NASA team doing just a superb job and continuing our exploration of the planets and Mars in particular, and again, returning or launching and returning U.S. astronauts to the U.S. It's a great accomplishment, and I congratulate NASA and the whole team of SpaceX and the industrial team for all the great work that they have done.
Yeah, that was a great moment for the United States. Let me ask you, most of our speakers have been at least saying something about COVID-19. Has that changed the way the NRO has had to operate on a daily basis? Have you had to change sort of your business rhythm?
Well, I mean, COVID-19 has changed the world, right? And we're no different. Yes, I mean we've had to change, but fundamentally we have continued to meet our mission. It's a requirement that we do that. There are impacts that we're looking down the road, as everybody is. I mean, we're not through it yet. The implications for our people, when you just think about it, with social distancing, the inability to travel in some cases, to go to other countries, to visit family and friends, takes a toll on people, and we work hard to make sure that we provide the flexibilities to support our dedicated team so that they can continue to operate in a safe environment. So here we're practicing social distancing. We wear our masks. Right now I'm not, but otherwise you'd see me like this walking the halls.
Yeah.
We've had to adjust. One of the big things that actually what's happening right now. 6 months ago, roughly, when this pandemic started, we wouldn't be able to do this conference this way. I wouldn't be able to participate, but since then we found a way to communicate, over open channels. Otherwise, from NRO, everything was secure communications. So we've had to adapt and develop, a broader suite of communications techniques. That may sound easy to many, but it isn't easy when you're working in the environment that the NRO does. So
Yeah.
yes, we've had to adapt, and we believe we've done it well. We've continued to meet our mission, and so far we're on track to meet our commitments for this year and going forward. Although I expect there's going to be continued challenges as we, as an organization, and as a country, and as a world, work our way through the COVID-19.
Yeah, super. Thank you. As you discussed in your talk, small satellites played an important role, very important role in the early history of the NRO. But now as you look forward to the future and your integrated hybrid architecture approach, sounds like small satellites could once again be able to really help achieve your mission. Can you comment on maybe the timeline for how you're going to roll this out? You know, what's it going to look like 3 years, 5 years, 10 years from now?
Well, I really can't talk about the specifics of the architecture, but as we said, there's a role for the whole spectrum of capabilities that are out there and available to us. When you think about what we have to do, fundamentally we look at the Earth, and to do that, we can do it with single satellites, perhaps, and constellations of them. So constellations, you would tend to think of smaller systems that we can use to accomplish that. We also want to take advantage of the commercial products that are out there that are doing things, and they're a fundamental part of what we're doing. We started our commercial working with NGA that to acquire commercial imagery. We're going to continue to do that with additional awards this year. We have a broad area announcement out on that. We're looking to expand outside of imagery into RF as commercial organizations are off looking at that. And many of those are using SmallSats to accomplish that.
Yeah.
So we want to build, we absolutely have to build, and if it's available, we want to go off and use it. And from a technology standpoint, whether it's for demonstrating a technology or for utilizing it, we want to use the vast array of capabilities that are out there, including SmallSats. Of course, it presents challenges too. As you have a more proliferated architecture, we have to develop ground systems that are more capable and more able to fuse data from different sources, perhaps taken at significantly different times or different lighting conditions. And that's going to require, again, capabilities that we didn't normally have before. So basically what I'm saying is we're going to use all the capabilities that are out there, regardless of what their size is, and we need the talents of everybody, from people that do software and algorithms to people that design and build spacecraft and constellations of spacecraft.
Yeah, that's fantastic. That's fantastic. So one kind of add-on question that we're getting here for some of our listeners is about the award. There was a Space News report that the NRO would award these multiple commercial imagery contracts by year's end. And they talked a little bit about potentially using commercial satellite radar providers. What about some other things maybe that you could use the commercial industries providing, things like maybe data links or launch, things like that? Can you talk a little bit more about that?
Oh, sure. I mean, we recently, we recently had 2 launches on from our Razor contract from New Zealand, which were, a commercial launch vehicle, Rocket Lab's Electron vehicle. Very successful, very, very pleased with that. We're going to continue with the Razor activities for launch. And yeah, of course, with communications, using commercial links is always available to us. As I said, we're going to take advantage of what's out there. It's important for us to spend our resources wisely, and we want to, if the system is available and capable and available, we're going to use it, and we're going to build and develop only those things that we really need to build and develop to acquire the information we can't get other ways.
Right. So here's another question that came in from one of our listeners about somebody had watched your talk, and it said that you talked quite a bit about, the CubeSat kind of mass and size. They're wondering about maybe, are you also looking into microsats or larger ESPA class type systems to augment as well? I guess the question is, are you looking across the entire gamut of sizes of satellites?
Yeah, I would say yes, we are. I mean, and again, as I said said before, are you still there?
We're here. I can hear you. Yeah.
Okay, because
Yeah.
my computer just did something strange.
Oh
So,
yeah. We've got
uh,
some glitches, but it's going well. We hear you great.
okay, great. That's good. So, so the question was, are we going to look at using the entire gamut of capabilities that are out there? Absolutely. As I said, when you think about what we have to do and uh, in order to be effective in utilizing space and accomplishing our mission, um, uh, we want to use all of the capabilities that are there to meet the mission. And part of meeting the mission is developing new capabilities and new technologies. And if we can get them up faster to go off and prove that the systems work, I think I mentioned that we've looked at computer processors that were used in the oil industry um, and sent them in space because of their size and their capabilities. We want to qualify it in space. That's the easiest way to provide assurance. There's many other technologies that fall into capabilities or sources like that we want to continue to use, and we want to get them up there as quickly as possible so we can put them in the systems that they need to be in and be able to know that they're qualified. So that means we want to use the full spectrum of capabilities that are out there.
Awesome. Here's a question. You just mentioned Razor. Is the Razor program going to meet your SmallSat launch capability needs alone by itself, or are you going to have to consider other contractual means or other awards for launch to support all the things you're planning on doing?
Well, one of the advantages of small sats is that you can launch them individually or depending on their size. You mentioned ESPA rings, you can use that. You can co-manifest them. We can use the small sat dispensers. There's many opportunities there. So I would say, yes, we're going to continue to use Razor um, to launch small sats, but that won't be the exclusive launch capability that we'll use.
Okay, got it. Another question here was hybrid architecture. For the hybrid architecture, like the one you discussed, I would assume there will be a higher degree of coordination, maybe some autonomous operations required. I did see you made mention of that in your talk, and certainly that's in some cases, obviously, but are there some key, I want to call them tools or key features or things that will help you, mission planning tools that will help you with these multi-satellite, multi-ball constellations? Are there any gaps that this small satellite community can advance to help you get better at what you need to do?
Oh, absolutely. As a community, we're still learning how to coordinate, um, the activities of multiple things, on the ground, in the air, and now as we're talking in space. So yes, I mean, we're going to need to, figure out what's the best way to operate those systems in space. There's going to have to be, particularly as you proliferate them and you have more and more of them, more automation required because you can't have a person sitting at a console and controlling tens or hundreds of satellites, as the case may be. They're going to have to be the satellites themselves are going to have to be to some degree able to take care of themselves. So there's a degree of autonomy there. You're going to have to coordinate what they're doing to make sure that you're obtaining the information that you need in the most effective way. In our case, we're very interested in resiliency and maintaining the capability of the system through all kinds of conditions. In which case, we need to know how are we going to self-heal the architecture if we suffer any losses for any reason. So all of those play into the ability to operate it. So artificial intelligence and machine learning on board the satellites to help us control the constellations is absolutely critical. And then when you think about ground systems, we're going to need similar types of things on the ground because we're going to want to fuse data from multiple sources. And just thinking about it, They're going to have different look angles, different lighting conditions, a whole bunch of different things that we're going to have to go off and address and coordinate. Anybody that's developing these capabilities. So it's not just an NRO type of a thing. It's going to be something that any organization developing constellations of systems is going to have to deal with. And we're sort of seeing that with the large communication systems that are going up there. So yes, we need people that understand artificial intelligence, that can apply machine learning, that can develop algorithms for stitching together various data sets, that can look for trends and in large data sets. I'm trying to think of the word right now. I can't think of it. Dealing with large data sets in general. So yes, we're going to need all the capabilities that are out there.
So that leads to a good point. We've got several questions coming in on this, but as you know, you're going to have to stand up probably a lot more staff to help with this. But small satellites have always played a role throughout the academic community, and the academic community is in getting them engaged in what you do at some point when they graduate is going to be a big help for you and your staff. You talked in your talk about the NRO cadre internship program, and I applaud you for that. It sounds like it was very well done, so good job there. But I've heard from several others throughout the academic community who welcome more engagement with the NRO, right? Things like, have you thought about, working with seniors and grad students and university capstone projects or senior projects and things like that as ways to sort of augment what you've done there with your cadre program?
Hey, Pat, that's a great idea. We're just starting. The NRO cadre is only about 5 years old, so it's a relatively new group of people, if you will. So that's a great idea and something that certainly we want to look at in the future. Our first set of interns are this year, and we're partnering with other organizations. I mentioned we partnered with NASA on it as well, because again, there's a lot of similarities in the work that we do. So yes, we do want to engage more with universities at the student level. We do have engagements with universities, as you well know. But to be able to engage with the students through intern programs, through projects of relevancy, through academic advisors, are all things that we are pursuing and will continue to pursue.
Yeah, awesome. Here's an interesting question about reliability that we received. It says, I would assume the typical NRO spacecraft mission needs very high reliability with a significant amount of redundancy in subsystems. In your opinion, will the NRO be able to attain the same level of reliability with small spacecraft that are doing pretty much the same mission?
Well, certainly we're going to have to look at reliability and resiliency in whatever we do, because our data is absolutely critical. There's many ways of achieving reliability. You mentioned one, with redundancy. There's also high quality parts that allow you to do it. There's testing that allows you to do it. There's also strength in numbers that one can look at, and there's also a reasonable refresh rate. They all come with pluses and minuses in terms of what you need to do to achieve the robustness or the reliability that's needed. So I believe we can achieve what we need. Again, it's not going to be one solution for everything. Ultimately, physics determines what you need to do. And sometimes you need large apertures, sometimes you can use small apertures, and sometimes you can do it with a combination of those
Right.
and distributed architectures. So, we're going to go off. We're going to make sure that we have the reliability we need to meet the mission demands. and go forward from there. But I have every bit of confidence that we can meet the reliability needs, whether it's with small sats, constellations of small sats, or larger spacecraft. We'll find a way to do that.
Fantastic. I've got another one here that came in. This kind of ties into what we were talking about a little bit earlier with sort of the educational aspect of things. But someone is wanting to know, are you using in any way some of these small satellite missions as a workforce training activity? Now, you're using them as part of your mission, but also that's kind of a good practice ground too, right?
Well, absolutely, and the answer is yes. I mean, we are using the small sats, in various programs here, to do just that for people, both inside the NRO and outside the NRO to get experience in developing satellites and operating satellites and developing the instruments that go on satellites. So yes, yeah, we are using those, and I expect we'll be doing more of that in the future.
Great. I've got a few questions here about graduating engineering students. At the time I graduated, I wasn't smart enough or probably knew anything about the NRO to even know to call you all. But, we got a question here that says, what advice would you give to graduating engineering students who are interested in a career in the NRO?
Well, Pat, when you and I graduated, the NRO was a secret. So we sort of had a apply elsewhere and then find out about the NRO. But we're not a secret anymore.
Yeah.
And we have a cadre. So there's many ways to come and work at the NRO. We are hiring. So if you want to contact us, just go to our website and there's information there. For those of you who are in the military, there's opportunities for you to come in that way as well. And I would encourage you to just go to our website, look us up, and all you got to do is Google NRO. Well, maybe National Reconnaissance Office might be the better way to do it, and go there, and it will tell you how you can apply for jobs here. Or if you know anybody that is at the NRO, I would say, if the conference wasn't virtual, I would say go up and talk to somebody from the NRO.
Yeah. Yeah.
And get their card and use that as a way. But feel free to contact people at the NRO. As I said, we're hiring, and we're very interested in getting recent graduates at the undergraduate all the way through the PhD level in all fields.
That's great. That's great to hear. We've got a lot of questions coming in about your relationships with other government organizations, U.S. Spacecom, the Space Force, SDA. People are asking about, how are you going to move data around? Are you going to utilize the SDA transport layer or do your own transport layer? How's that all shaken out? Because we're all hearing a lot of things. I'm not sure a lot of us have a clear picture of how that's moving forward.
I would say, the NRO is a good partner, and they have good partners that we're fortunate to work with. U.S. Space Force, the U.S. Spacecom, SDA. We work with them all. Space Force, U.S. Space Command, and SDA are relatively new, but still they've been around, in one form or another. And we have a very good relationship. I talk with General Raymond on a regular basis. And right now he's both Space Force and Spacecom, and I speak with Derek. So we have a very good relationship with those organizations. Again, we don't want to duplicate efforts. It's our job to do what it is that we need to go off and do and take advantage of those capabilities that are out there. I had mentioned before, the commercial capabilities, the capabilities from from universities that are out there. The same is true with other government organizations. So if the capability exists, we will use it, and vice versa. If we have a capability here, they will use it as well. So we have a good partnership. We continue to have a good partnership, and we have good partners, and we continue to go off and work together to make sure that we're providing the most efficient systems for the nation that we can.
That's great to hear. Another one that ties in a little bit here that we're getting is, what do you see as the main drivers between, this is sort of the make-buy kind of decision question, you know, government owned and operated versus commercially owned and operated, because there's a lot of capabilities coming online from commercial systems, a lot of government systems. How do you go through that process of who you're going to use, how, when, all that, those sorts of things?
Well, you know, that's sort of a complicated question, and it sort of depends on the system. But fundamentally, we look at what's available out there, like we're doing. We mentioned earlier about looking at commercial imagery. We look at what the capabilities are out there, and how they play into the needs for the nation, and determine whether we can solve the problem entirely with an existing or proposed commercial system. And then, of course, if it's proposed, we look to see, you know, what its horizon is for being available. And then we determine whether or not we buy it or we build it. And of course, by build it, I mean, we go out to industry principally to get it built. But you know, that's a process that's dependent on a specific activity. So I can't give you a specific answer, but the general answer is we go off and look at and see what's available commercially, see if it meets the needs that we're trying to achieve. If it does, problem solved. We go off and get it that way. If not, we go off and we'll develop our own systems, and we'll work with industry and academia to go off and do that. I also think there's another role for government in here and the NRO, and that's to advance capabilities and advance technologies beyond what you can just acquire today. So we have that responsibility as well to go off and demonstrate and develop things that people either haven't thought of before, or develop capabilities that are very, very cutting edge, so that we can go off and improve our understanding of adversaries' intents, and keep the world better protected. So it kind of falls into those three bins: buy what you can, develop what you can't, and think about what the future is going to look like, and figure out how you can go off and make that future a reality.
Yeah, that makes a lot of sense. That makes a lot of sense. So we are getting just an absolute ton of questions, which is great. So I apologize for bouncing around a little bit on different topics, but here's a good one, which is really important to the country and to the global space community. But this one talks to the rapid proliferation of vehicles in orbit, right? Something different than we were accustomed to dealing with 20 years ago. So you got all these small satellites, you got the large satellites, you got the commercial constellations. There's discussions about, you know, collision avoidance, orbital debris maneuver or removal, things like that. I've been in a lot of discussions with NASA. They're working hard. They're working with the European Space Agency to try and deal with this, because this is not just a United States issue. This is a global issue. But, you know, what roles, if any, are the NRO playing in coming up and crafting solutions to try and help make sure that this doesn't become a bigger problem in the future for us?
Well, of course, we're working to make sure that our systems don't become debris,
Sure.
and dealing with that to dispose of them at the end of their life. So, that's what we're doing. You're absolutely right. It is an issue that needs to be addressed, and it needs to be addressed as you said, it's an international problem, and we need to develop a solution, an international solution to it. So we like all the other space organizations have to deal with it every day, and we do. But we also, work collectively through the appropriate organizations to understand what the risk is and to work together to make sure that we minimize it. As far as reducing the risk, the NRO's role is to make sure that we don't leave debris in space, leave inert systems up there. It's no longer acceptable. When you were, back in the time before any of us were working, that was okay, but it's not okay anymore, and we need to take action to make sure we don't create debris.
Yeah, it used to be little satellite, big space, but it's kind of getting not that way anymore, right? One of
Correct.
the things that kind of relates to that is, what are your thoughts on the sort of the 25-year disposal rule? Is that fast enough? I know that some of our small satellite provide, if they fly a 3 or 5 year mission, how do you feel about them sitting up another 20 plus years? If they're in LEO, something that you could, deorbit quicker.
Well, as we get smarter and as systems, are put up there, I'm certain, every so often we need to look at the rules and regulations that we put in place. When the 25-year requirement was put in there, it made a lot of sense, and I'm sure, people will be and should be looking at that to see if it remains relevant.
Okay, I've got another cool question from your next generation of engineers and scientists there at the NRO. Question here came in and says, do you also have opportunities for international students or graduates? We would like to be involved as well.
Well, that's a little bit more of a complicated question. We do have relationships with international organizations, and I would say, I'm not the right person to ask, but go to that website and ask the question.
Okay, got it. Okay. What about, so we talked a lot about, sounds like people want to know more information. If someone wants to reach out to you, either they're a student or they've got a great idea or a great project, they want to, sit down and talk with you, what is the best way for them to engage with your team there? Because I know you got a large team and they're broken into many different segments. How do they reach out and get access to you all?
So there's a number of ways. Probably the best way is we have things called broad area announcements, and they're published in a variety of places, but there's a government website that you can go off and look at, where people can bring in ideas. And in fact, I have a couple of examples that I can give you here, which somehow or another has slipped my mind all of a sudden.
Take your time.
Yeah, there's the ArchF program, which is one that you can go off and look up. Most of the opportunities come through our AS&T, our where we do advanced technology. And if you went to the NRO website, you'll see many opportunities there for where you can go off and look at things. There's some that are, in fact, right now, that I mentioned the ArchF program. We're looking for proposals to be submitted by the end of this September. That might be a little bit too soon, but they're more or less annual opportunities to go off and do that. So I would again, ask you to go to our NRO website. We'll publicize things there. Look at AS&T, and sign, S&T, to go off and see where there's a number of opportunities for you to go off and participate. And then, of course, through our intern program, you can come in here and participate directly as part of that, and either participate in things or even, as I encourage all the interns to do, um, uh, as somebody that's currently in the system learning new techniques, tell us what you're learning and tell us what you think we could do better. So I would say there's a number of opportunities to go off and do it, to propose, to actually build something through any one of our broad area announcements that you can go off and see. As again, they're annual type of activities that you can participate in, or the intern program, and come here and work and have an opportunity to propose ideas that way as well. So those are
Yeah,
just a couple of the ways that one could do that.
yeah. There was a question about a comment about there's also the director's innovation initiative too, right?
Yes, indeed.
Coming
That's what
through.
I couldn't remember.
Yeah.
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 I should know that one. It says director in it, doesn't it?
Yeah. Yeah, that's right.
That's also annual, and that one is, I think it closes in August, so that would be even
Yeah.
tighter schedule.
Yeah, so I've had a lot of questions. There's a lot of good questions here. One of the questions is, have you seen Space Force on Netflix? And what would be the best
Absolutely.
analog for the NRO?
Absolutely. Yes, I have watched Space Force on Netflix. I really enjoyed it. I won't comment on its accuracy, but it is entertaining, and I really very much enjoyed it. Yes.
Yeah, yeah, we've got a lot of good questions here. Let me see. I'm still scrolling through some of these things. Transformation. Let's see. Boy, there are just 100 ways we could go here. Is there anything? Can you think of anything that we haven't talked about today that you wanted to get out? I mean, you got all the best small satellite geeks in the world here today. Are you? Is there something you want to get out to all of us and let us know how we can help you and what can we do to support you?
Well, I would say, keep on innovating, and even though the NRO has been using SmallSat even before it was known as the NRO, the real engine is from people that are out there experimenting and developing, new capabilities, and keep on pushing us. 10 or 20 years ago, the viability of SmallSats to do some of the things that they're doing in Earth observation and in telecommunications. People, not everybody would have believed it. I mean, some of us recognized that there was some great capability there, but it's because of this forum and the SmallSat community that's demonstrated those capabilities, oftentimes with their own resources, that has really, changed the way we look at space and the way we do things. So I would say, keep on innovating, keep on developing, keep on pushing all of us to think about how we can use those systems better and in different ways, and also look at how we can improve our ground systems so that we can more efficiently and effectively control those constellations, deal with the management of a large number of objects in space, and to fuse all of those data sources now that are up there, that can give us an entirely new understanding of our Earth and our surroundings. So that's a real capability. And the other is, the NRO is a great place, and if you're interested in building some really capable systems of whatever scale, um, we're interested in you becoming a member of our team. But I think the biggest thing is keep on innovating, keep on developing new capabilities, and keep on pushing us so
Yeah.
that we stay at the forefront and use space in the most effective way possible.
Yeah. If you have time, I've got a couple more questions here. One came in from Space News. It says, how's the NRO feeding the new entrants of their workforce? How are you making security clearances possible? How does that process work?
Well, I mean, fundamentally, it's the same as I mean, getting a security clearance is pretty much the same. The main thing is that the government has looked at ways to streamline it, and we're seeing it being much more effectively done. So I would say getting a clearance is not a difficult thing to do, and the government is working very, very hard to streamline the process and make it more efficient. And the NRO is a participant in that, and we're seeing the benefits of it as we're able to get people cleared at a higher rate than we have been in the past.
Yeah, fantastic. This is a cool question that I had not thought of asking, but it was brought up about the colony program many years ago. And those of us in the SmallSat arena knew this very, very well. But it says around 10 years ago, the NRO jumped into the small satellites with the colony program. It wasn't quite as successful as we probably all wanted it to be. But what were some of the things that you learned and getting past that sort of negative perception about small satellites or CubeSats, right? To where today now we're pushing pretty much full bore and working hard with some small satellites.
Well, it's a little bit hard for me to answer that question because I wasn't involved with that program. But I mean, I think I can generalize based on my experience. In the past, I've been involved with space for more than 30 years now, and any new capability comes with growing pains. And I'm sure we had the usual. I know we did. I mean, I lived it in another world where we had early failures. Promise outstripped the reality initially, but like everything else, it matured and it grew and it became better as we looked at it. So. I applaud the NRO for getting into it early and sticking with it, and I applaud all the other organizations that did. Any new capability, requires dedication to mature it to a point where everybody sees the value of it and everybody wants to take credit for it. I think it's great that the NRO is an early adopter. I think it's great that we stuck with it. I think it's even greater that as a community, we stuck with it, and now we've created, whole new capabilities and fostered whole new companies and organizations to make our lives better overall. When you think about it,
Yeah.
Everything from being able, Earth observations to telecommunications. It's all
Yeah.
made our life better, and it all started with the reemergence of small sats in the 90s. So a great idea, and I'm glad that we stuck with it.
Yeah, I hope you realize how important your positivity about the small satellites and what comes from our community is doing for this community. You've got a whole bunch of people cheering you on to be successful there. So just know we're all rooting for you. One final question I'll give to you, and then I'll let you go because I know your time is short. But if you were able, let's be positive for a second. Let's assume we're we're back in Logan next year, and we have the SmallSat conference here, and you're walking the show floor, right? We're able to get you out here, and you're walking around. And what would be the thing that you would be most interested in seeing? You know, what would pique your attention and have you go over and sit there for half an hour and ask questions?
The people, the students in particular. You're the next generation. You're going to make the world a better place. And I tell all engineers, particularly new ones, our job is to make the world a better place. Sitting down with the students and seeing your enthusiasm and your dedication and your willingness to try things that some of us are a bit reluctant based on our experience to try is what I would really like to do. So if I'm there next year, and I hope I am, let's just say I will be there next year. And when I'm there, I would really, really like to engage with the next generation of engineers and scientists and explorers as they start to demonstrate what they really want to accomplish. When they get 10 or 20 years down the road. So that's what I'd like to do.
Fantastic. Well, listen, we're rooting for you. We're happy you're there, and it's just great to see you today. Well, we're going to wrap up. We have, by the way, webinars just planned all day, so we've got kind of one after the other. There's one starting here in just a few minutes, but thanks again, Dr. Scalise. That was absolutely tremendous. Your talk, I thought, was phenomenal. I really enjoyed the Q&A session. I hope a lot of other folks did too. And also, again, a big shout out to your staff. They were phenomenal. So also thanks to all of our listeners and all the people who sent in questions. I was getting rapid fire questions, and we were doing our best to curate them, but it was good. But with that, everybody have a great day. Stay safe, stay healthy. And I look forward to seeing you all back here in Logan the next chance we get. So go SmallSat.
Absolutely.
Thank you, sir.
Thanks, Matt. All right.
Thanks.